Now let's continue with the introduction. So in the past, we listened to an audio broadcast through a radio and videos through a TV. But now we have the internet. Mic drop. That's it. With the help of the internet, we can text anyone, we can send images, we can send audios, we can stream audios, we can stream videos, and whatnot. That's why we had to divide audios and video services into three broad categories. The first one is streaming stored videos and audios. For example, the on-demand platforms, for example, Netflix and Amazon Prime. Those have stored songs, movies, and TV shows, and we just stream there. Then we have streaming live audios and videos. For example, internet radio. Like nowadays, radio is we can listen to radio even on the internet. And third, we have interactive audio and video, which is, for example, video call. Like we are interacting with anybody through audio or video. Even meetings are held nowadays on the internet. So, but there is a problem. Before audios and video signals can be sent on the internet, they need to be digitized. But why? Let's answer that question. So, when sound is fed into a microphone, an electronic signal is generated, which is known as the analog signal. Then we have to digitize that analog signal into the digital signal. Only then we can send those audio clips to somebody else. And now let's cover digitizing videos. So each frame is divided into small grids. In a video, so first of all, a video is a combination of images, and each image or each frame is divided into small grids, which is known as pixels. And there are a lot of pixels, a lot. And then digitizing your media, what does digitizing do? Digitizing our media creates extra storage space so that we can send those videos and audios easily towards the internet. Then we have audio and video compression. So we have digitized the video, but now why do we even want to compress a video? So sending audios or videos over the internet requires compression, because we can't send GBs and GBs of images, videos, or audios. So first let's come to the audio compression. So audio compression can be used for speech or music. There are two types of audio compression. The first is predictive encoding, and the second is perpetual encoding. So what is predictive encoding? So in predictive encoding, the difference between the samples are encoded instead of encoding all the sampled values. This type of compression is normally used for speech. So the difference between the samples of two voices, that's been encoded here and then compressed. Then we have perpetual encoding. So first of all, perpetual encoding is based on the science of sounds, and some sounds can mask other sounds. And what's masking? So if I speak something and I have my friend right over me, besides me, and he is speaking something, so if I'm speaking louder, so his voice will not be that loud, and they'll mask each other. My voice will mask his voice. So that's masking. And then we have frequency, two types of masking: frequency masking and temporal masking. So if I am in a gym and I'm working out, and then the audio is very, very loud, and again the same friend is sitting there and I'm not able to listen to him because the audio in the gym is very loud. That's known as frequency masking. And then temporal masking, when we are listening to very loud audios, like I'm wearing earphones, and in those earphones, I'm listening to audio at a very, very loud voice. And when I remove those earphones, for a few seconds, I can't hear anything. That's temporal masking. And MP3 uses these two phenomena, frequency masking and temporal masking, to compress audio signals. This is how audio compression works. And then we have video compression. So, as I told you earlier, videos are a combination of images, a lot of images. And to compress videos, we have to compress images. Then we have again two types of video compression. The first one is JPG. So the full form of JPEG is Joint Photographic Experts Group, and the second one is MPEG, the Moving Picture Experts Group. So we perform such type of compression to reduce the size of the file without damaging its quality. And by reducing the size, we can store it in huge amounts, which was not earlier possible. And reducing the size of images will also improve the efficiency of the system, as it will get less load on it. Self-explanatory. Then, how do we do it? So we convert the RGB, red, green, blue color into Y, CB and CR format, yellow, crimson blue and crimson red format, because they contain less space and they are very good to eyes. And then we replace the size of the pixels in downsampling, and then we divide our images into 8 pixels and then perform DCT. So what is DCT? So DCT is a fundamental tool in modern image and video compression. So it's just a tool, and it is used to convert data from pixel domain to frequency domain. And this is done to reveal insights about the information contained in the pixels. And after what we do, then we compress our data using various encoding methods. There are many encoding methods. We can choose anyone. And then in the second stage, we decompress our data back, then convert it into the image and to its original color format, and we have the compressed video. Then the second one is MPEG. So MPEG follows an algorithm in which the data is compressed into small bits so that they can be easily transmitted and decompressed and then encoded using DCT again. The compression rate of MPEG is high because it doesn't store the complete frame, but it only stores the changes that have been made to the frames. Hence, it reduces the overall size of the file. So this is how the compression works. And we got to know why compression is very, very important, because we don't want to send GBs and GBs of data over the internet. And here we got to know why digitizing audios and videos is important, because of the signals here, and then to create extra storage space here. And here we got to know about how large the internet is, how are you using it, like we can do anything we want. And then we learned about the 3 broad categories of audio and video services. So now let's meet in the next video again, which will cover another topics.